Morning, class. Welcome back after a nice break. I hope you all feel a bit more rested and ready to learn. Um, Today it's going to look a little different. First of all, I know you can't see me. Sorry. Trying to make the video look a bit better without having to have my face in it necessarily. So hopefully this works. But nonetheless, today is going to look a little different. First things first, I want to talk about what we talked about right before we went on break. So this idea of density, um, as you can kind of see here on my screen, um, and kind of what that looks like. And then we're going to figure out how to calculate it. And we're going to do something called a digital lab, which we've done a little bit in the past. Um, so we'll see how we get on today. But first things first is I want to kind of do a bit of a review on density. So density, what I did last in the live meetings, I had you guys take a second to think about what you think the term means. And then this idea of what is heavier, a pound of feathers or a pound of cement. We came to the conclusion that they're the same weight because they're both 1 pound, right? But we need to think about what each of these pounds would look like, right? So if I have this little image here, right, 1 pound in lead or cement or whatever it is going to look a lot smaller than this pound of feathers, right? To get a whole entire pound of feathers, you're going to need a lot more feathers, right, than for cement or lead. So this is how we can think of density, right? Density, or the object's density, is related to a substance mass and volume. So if we have this idea of any substance, it could be feathers, it could be cement, it could be lead, it could be wood, gold, silver, whatever it is, if it has a really large volume, so for example, maybe we have styrofoam, right? Styrofoam is that white stuff used to kind of protect packaging. It could take up a lot of space because we know that volume is kind of the space that an object takes up, but it has a small mass. So that styrofoam takes up a lot of area, but doesn't necessarily take up have a lot of mass to it, right? It's not very heavy. Do you think that would be a very dense object? No, it's not very dense. Because it has a really large volume but a small mass. On the other hand, if something has a small volume, so maybe like a bowling ball, they're pretty small, you fit in both hands, right? But a large mass, they're heavy sometimes, they're pretty heavy to pick up. What do you think its density would be, large or small? And it would be a bit larger, right? Because it's taking up a smaller amount of space, but has a larger mass. And then what we did is we went through kind of a few examples. We talked about custard powder. We figured out how to find something's density. And that's using this triangle here on the right, okay? Anytime you see these triangles, they kind of explain to you how to solve for anything in that triangle, right? So if you need to find an object's density or a substance's density, right? If you want to find the density maybe of a piece of wood, you need to take the volume of it. So remember, that's length times width times height. Find the mass of it. We know how to find the mass of any object, right? You just put it on the scale, mass scale, and take that reading. And then you use this triangle. So if you're looking for density, you can cover that up. And then since mass and volume are over top of one another, that means divide. There's also a little cheat sheet down here for you. So when you're trying to find density, density equals mass divided by volume. If you're trying to find mass, you cover up mass, and they're right next to one another on this triangle, and that means multiply if they're right next to one another rather than over top of one another. So mass is equal to density times volume, or if you're trying to find volume, mass and density are over top of one another, that means divide. Mass divided by density equals volume. So you should have this in your copy already from last week. And so what we're going to do today is I am going to put up on Google Classroom a website for you guys to go to, and it's a simulation. And it looks like this. I'll bring it up now. So this is kind of like over here on the left, you see this simulation, right? There's a what looks like a beaker of water here, and I'm controlling this gold bar. I know it's kind of choppy, but you can see that it's moving around. So on the left, we have a beaker full of water. It has about 25 milliliters of water. And on the right, we have a mass scale, which we use to find the mass of something. So what you guys are going to do today is you're going to go to this website, And you are going to find each of these objects here down on the lower right hand corner. So you have gold, you have lead, foam, ice, iron, wood, rubber, and even a mystery item. And you're going to find each of these density. Now it might not look like this exactly. You can play around with it when you first get to the website. But to get started, what you need to do is you need to turn this fluid into water. Click turn this fluid into water. And then you need to click gold or lead, whichever one you want to start with. And that'll bring you up the page that you see now on my screen. Okay? So if we remember correctly, going back to our formula, and I have a little my cheat sheet down here. So I'll do the first one. I'll do gold as an example. Okay. So clicking gold, we need to know to solve for an object's density, and I'll bring you back to the page here. If we want to solve for a object's density, if we look at our cheat sheet, we need its mass and we need its volume, right? So let's go ahead and find those two. Okay. Sorry. So let's find those two. So gold's, we can find its mass really quickly. So if we need to find its mass, we take, I'm just going to do this real quick. So we take the object, place it on the mass scale, and it comes out to be 40.53 grams. So I'm going to go ahead and put that into on my sheet of paper over here, 40.53 grams. Place that down. Okay. So, oh, I'm missing something. Grams. Always need your units, right? So you put that there. I can delete that. Ooh. Let's just do this. Okay. So 40.53 grams is its mass. Then, how do we find its volume? So remember from a few lessons ago, if you need to find any object's volume, you can use a beaker of water, place the object in there, and notice that the volume changes here, right? So to find the object's volume, you take whatever its initial volume is, so whatever it is before you put the object in. So if I'm using my scrap sheet of paper over here, so initial volume equals 25.5 milliliters. Okay, I'll make this font a little smaller. Oops. Ooh, it's still pretty big. So initial volume is 25.5 milliliters, okay? Its final volume when you put it in the beaker is whatever it rises to after it's completely submerged. So we find that it's 27.6 milliliters, so take that down. So final volume is 27.6 milliliters. Go ahead and put that on my sheet of paper. And so to find the object's volume, you will take the final minus the initial. Okay? So final minus the initial. So object's volume then, so the final is 27.6 milliliters, 27.6 milliliters, minus the initial volume, which is 25.5 milliliters. That then equals, I'm going to put that into our calculator real quick. Let me grab my phone. So 27.6 minus 25.5, that equals 2.1 milliliters. Okay? So our object's volume is 2.1 milliliters. So that's important. So let's go ahead and take that down. Get rid of this. Place 21 point. So then all we need to do, we are going to then divide. Remember, so if we go back again one more time. Oops. And shift this one. There we go. Go back again to our triangle here. We see that to find an object's density, you have the mass divided by the volume. Okay? So mass, so our mass up here divided by this line, the volume, then equals, so 40.53 divided by 2.1, I'm going to pull out my phone calculator again, equals 19.1 Just gonna draw it 19.3, and then remember our units for density is grams per milliliter. Okay, always have your units. So that is gold's density, right? No matter the size of the piece of gold that you have, its density will always be this. If I were to change the volume, if I were to make this piece of gold, you know, a lot bigger, the mass would change, right? Because you're adding in more gold, and that would mean that the density always stays the same, okay? So what you're going to do then is you're going to go ahead and you're going to go and do lead. You're going to take it, you're going to place it on the scale. Notice that the grams changes here. Take that down, and then you need to find the object's volume by placing it in the beaker. And you're going to find lead's density, and so on and so forth. And then even until you get this last one here, this green one, the question mark, question mark, question mark one, you're going to try and figure out what that is. And how you guys are going to do this is I will also post a page, another web page for you guys to use, and it looks like this. And it has a bunch of different substances, steel, iron, brass, copper, even all the way down to things like a white dwarf star and black holes. All these things have their own densities, right? Like a black hole has a massive, massive density. But notice that we got gold right. Gold's density is 19.3. So what you're going to then do is, I promise, on this page somewhere is the question mark, its density is on here, and it'll tell you what object you're finding, okay? So what you do is you'll find the density for each of these objects, and then for the green one, you're going to try and tell me what object it is, okay? You can also use, not all of them are on this web page, so you might not be able to check all of them, but some of them are, so you can check if you're right. But I will also post a place for you guys to post your answers to, and better instructions in words, just in case you might have missed it. But hopefully that makes sense. And if you have any questions, please email me or comment, and I will try and help you guys out. So I will see you guys soon, and good luck.